Hi guys, welcome back to snt-networks. In today's video, we'll be talking about the third episode in the series, network engineer interview questions and answers from basic to advanced. So here again, we discussed around 5 questions in this particular series, and we are going to a bit medium level, right? Okay. Basically, in this one again, we'll discuss about 5 questions, right, which will definitely help you with your interview, and which will also make you a bit more confident about how to answer the questions. So the first question is, you are unable to access a website. What are the first few steps you would take to troubleshoot? Right. So in this one, the first thing that you would do is, for example, you would ask the interviewer if it is a new device or an old device. So if it's a new device connected, then I will check from the start to check what exactly is wrong, if it's getting the correct DHCP server, the IP address, default gateway, everything is correct in that particular device or not, right? And then after that device, for example, this is the default gateway for this particular, and then we have the internet. Okay, simple setup. So then what you'll do is you'll check physical connectivity. If this particular cable that is in between, right, uh, here is right or not. Okay, if the physical connection is proper, like check the NIC lights on the router switch and the device, then you will check, what you'll try to do is you'll try to ping the local host, right? You'll try to ping the local host, basically your 127.0.0.1, usually a loopback address, to check if your NIC card is working correctly or not. This is one thing that we tend to miss. This is again very important, and the admins out there would relate. Then you try to ping your default gateway to check if you are able to reach the server or not. So I'll write here in this fashion. First one is config. Second one is loopback. Then you ping default gateway. Then you ping a known IP. Like for example, what we do is to check if the packet is going out, we do ping 8.8.8.8, right? And then what you do, you check the DNS resolution, if the DNS resolution is working fine or not. In this one itself, you'll get an idea, because if you're not able to go for Google, but 8.8.8.8 is working, that means the IP is working, so that there is an issue with the DNS resolution. Then you check this. Then the simple thing is try with a different browser. Right, that could be a cache issue. And then now, even if this is not resolved, this is the normal policies I'm telling you. Then you go on the default gateway and check basically the ACLs, if you are allowing packets out or not. And then even this fails. So 7 is ACL and 8, even this fails. Then you do a hop by hop Wireshark. Or you can use the 9 tiles, the CLI. You can check on this particular CLI. For example, if this is ETH1 and this is ETH2, you can see using CLI that ETH1 has this particular packets and ETH2 has this particular packet. Basically, the incoming packet and the outgoing packet should match. Right. So you can check that. If there is a little drop latency, then we can understand. But other than that, this is the basic flow that you use. And with the Wireshark itself, we'll get a lot of things, like if there is if the server they're trying to reach is sending you a reset packet or something, right? So the whole picture will come out in the Wireshark. But these are the particular steps they need to you need to basically flow in this particular flow. You need to check so that you can basically resolve most of the 80% of the issues will get resolved right here in the first 6 steps, 6 or 7 steps. If it is more complex, they need to dig in further for the 7, 8, 9 steps. Right. Then the second one is, what is software defined network? Okay. So people expect for you to know all these things, understand all these things, even if you have not worked on it, but you need to have an idea of what exactly is software defined network. So basically SDN, Software-defined network. What is software-defined network? Software-defined network is an architectural approach basically for network management that separates the data plane and the control plane. Okay. This centralization basically helps you to control and be a bit more flexible. For example, if this is a this is a device, okay, firewall or device. Earlier, what used to happen was we have both the control plane and data plane on the same device. Now, because of software-defined network, we have data plane here for from devices where the traffic is flowing. But all of these are centrally managed by an orchestrator or a, you can say, controller. This is the controller where you have control plane, and these are the data planes. This is a very simple example for you guys to understand. So this is how software-defined networking works. So you can say that SD-WAN is also a software-defined network, wherein it's a type of software-defined network, wherein the data plane and the control plane are different. And moving on to the next question, what is, so I hope these two questions are clear. Okay. Third one is what is zero trust access, zero trust network access. Zero trust, so comparing to the older firewalls or traditional networking, what we had, or traditional VPNs, what used to happen was you're sitting at home, you try to connect to a VPN to your server, which is inside the network, or basically acts like a barrier between the internal and external network. So this is external, this is internal. Then you have your router resources, all of the resources servers here. Okay. So traditionally, what used to happen was once you're connected here, you get an IP address from the VPN. Once you get the IP address, you sort of belong to the network. You get the same IP address that belongs to usually the internal network. So you're treated equally. Okay. So only once you're trying to connect in this particular process, you are tested. Like basically host checker will be implied on you, security policies will be implied on you, all the packets here will be encrypted. Now in zero trust networks, what we basically do is it is don't trust. It's don't trust, always verify. So now what does this mean? It means that even if you are here or you are here, right, doesn't matter, it will always verify you. First of all, it will always verify. Okay. Second, first it is always verifying you. The second thing it does is continuous monitoring. So if you're verified once, periodically you will again be verified using the host checker and other policies to check if you're still compliant. And not just the device, the user is also compliant, that is also checked. Then you connect, usually what happens is, in zero trust, what happens is you don't pass through the whole network, right? You basically, in usual cases, what happens is you pass through your proxy device or your CASB. So nowadays, CASB, sorry, CASB plus your secure web gateway are combined all together. You pass through this and then you access. You get a direct connection between your what do you call this server, which is also encrypted. Okay, so you can say that you don't get an IP. It's sort of proxy access. You don't get the IP so that you're trusted. Ideally, you're not. Okay. Then we have also have here role-based access. Role-based access control. So you're controlled using your role. Okay. You get a particular role. Only that particular people who are in that role get access to a particular server or a particular application. Then you have segmenting. Segmenting, you can say that micro-segmenting of networks, so that if, for example, you have a couple of networks here, okay, and in particular networks you have some devices. So if one device is basically under attack or has a bug or is malicious, so the other sites are still secure because you have separated the whole network. So this is a different network. This is again a different network. So zero trust is basically this. Okay, and if you want to know more about it, I click on the I button. You'll get a detailed video which we have already created on that. So I think this is also clear. The next one is what is network function virtualization? So this is again an important question. So what is network function virtualization? Network function or NVF we say it is a network architecture concept that virtualizes network appliance functions that have traditionally been implemented in dedicated hardware, right? This allows servers like firewall, load balancers, IDS, VPN solutions to be deployed in software. So you can say that network function virtualization earlier, whatever was hardware, is being shifted to cloud, right? And then it is synced with your local data center. Correct. So it will give you the same function, but it is a bit more flexible. You don't really have to build a whole what do you call data center anymore. I know we do have it, but still, like, you get a more flexible option, right? And sometimes it provides even more security as compared. So what is the next question we have here is, I hope this is also clear. What is cloud networking? What are some key considerations? So it is cloud networking. Cloud networking refers to the infrastructure services that connect cloud resources that enable communication between them and on-premise networks. So for example, like we discussed this one. So is basically network function virtualization helps you virtualize applications that have been in physical mode, right? So now, you can't migrate all of them. So some physical appliances that you have, right, and you want to connect them to your cloud. Okay, let me just change it. Yeah, you want to connect them to your cloud servers that you have using, your network function virtualization, and this is your physical. Okay, let's just name it as physical appliance. So the way you connect both of them, right? The way, or the infrastructure that helps you connect your cloud to your local resources, the physical resources, is called cloud networking. Some you have you can't be very certain that they won't ask you this in an interview, because they do. They want to understand if you know the technicality properly or not. So, okay, we do virtualization. How do we do virtualization? We use virtual software formats, right? And basically, we try to do the same architecture in virtual format, correct? In cloud, basically. So that is network virtualization. But now I don't have all of them in virtualized. I have some physical appliances also. Now, how do you connect them? So the way you connect them is cloud networking. So basically, it's cloud networking is the network infrastructure and services, right, that helps connect cloud resources and enable communication between them. So you can basically say that cloud networking refers to infrastructure and services that connect cloud and enable secure communication between them with on-premise networks, right? Key consideration will be like security, scalability, cost, optimization. Uh, but the main thing you can say is integration. Like, how do you integrate the physical and the virtual platforms? Virtual, you can say that network function virtualization, basically. So it's just a term that you need to remember, right? I know you understand it, you might understand it, but it's always great to remember the exact name. Cloud networking connect physical and virtual. Then what is virtual? This thing, network function virtualization, basically architecture that helps you, you know, uh, you know, uh, basically virtualize the physical appliances, right, into a better like software or a this commodity, right? Cloud commodity. You can also have hardware that have virtual systems running on them, right? So I hope this is also clear. So this is a very quick video, this just going on details, right? So if you guys have any questions or want me to discuss any other questions, please do let me know, and we'll be back next week with another 5 or 6 questions, and we'll notch it up a bit. I hope this was helpful. Thank you.